Hi, I'm Dave Vernier, and I'm going to introduce you to our power amplifier. This device produces an output signal, and you can do it, lots of fun experiments with this, mostly for physics, but for other subject areas too. Yeah, this can produce an output of -10 to +10 volts, and it can produce a DC signal, it can produce a sine wave, a square wave, a triangle wave, or a ramp function. The frequency range is 1/4 of a hertz to 10,000 hertz. So lots of possibilities there. Show you the connectors on the power amplifier. This is the output terminals where you would normally go to the device you're powering. This is the on-off switch, LED for indicating power on. And on the back we have a couple important connections. This is the power to the power amplifier. This connection right here is used for connection to a LabQuest. And this one is used for connection to a Lab Pro, so you can drive the power amplifier from a Lab Pro in this case, or a LabQuest with this connector. But this same connector has a second use. You can use that as a way to monitor the current being produced by the power amplifier. So we're going to set this up for a demonstration now. I'm going to use a LabQuest, so I'll make the connection to this terminal right here, and over to the audio out connection for the LabQuest right there. And what we're going to do here is a demonstration of standing waves on a string. We're going to make the connections to the power amplifier here. So here we have an inexpensive speaker, which we're connecting with lead wires. But on the speaker we've used hot glue to glue on a little plastic cup. And on the cup we made a screw connection to a device where we can hook a string. Now this string is a stretchy string that came actually from a name tag that I wore at a convention. And then we've tie this to a ring stand, and we've done a little adjusting to get the string at a right tension for some vibrations. And what we're going to do now is lower the lights so that you can see the string better in this video. I'm going to start the power amplifier output at 10 hertz here. Now I've taken some time and moved the ring stand back and forth until I got the right tension on the string to get a nice fundamental vibration at 10 hertz. And now I'm going to change the output frequency to 20 hertz. And it's kind of fun to do this and show the kids the nodes and the antinodes. I'll now go to 30 hertz. And let's do 40. And here you can see the 3 nodes. This is a great demonstration to teach kids about standing waves on strings. So I think that can serve as a great demonstration, or you could use it as a lab with your students where you let them discover what frequencies produce the various standing wave patterns. Well, there are lots of other demonstrations and activities you can do with the power amplifier, and I can't resist showing you one more. So I'm going to get rid of all this stuff, and this time I'm going to hook up a small lamp to the power amplifier. Now this time I'm going to set the frequency very low, in fact as low as I can go here, 1/2 hertz, and I'm going to start the output. I'm at about 5 volts on this lamp. Now remember that we can monitor the current with the power amplifier, and I would offer this challenge. What would happen if we graphed the voltage versus time and the current versus time as this light bulb goes through this cycle?